Hello guys, welcome to Show Me How Geometry. On this discussion, we are going to learn how to apply operations to simplify fractions. All right, let's go. So first, we're going to learn how to add fractions or review how to add fractions. So I know you already know these things, but then some of us know these things, but some of us still need to review all those together so we can all be ready for geometry. So in geometry, adding fractions are a big deal. So you're looking at measurements. Some of them might end up being fractions, and you need to add them up to see, clean them up to see what your final results will be. All right, so let's go ahead and add this quickly. So these two fractions here, they both have the same denominators. So when you're talking about fractions, the top number is the numerator, okay? And the bottom number is the denominator, all right? So let's go ahead and just and go back and say the top is the numerator, just in case you've forgotten. And the number here in the bottom is the denominator. All right, so we're good. All right, so but since you can see that these two fractions we have here, I'm going to be very quick. So they both have the same denominator. So when they have the same denominator, so you call them when you have same denominators, you say the fractions are like fractions. So you have like fractions. So let's say like fractions. So when you have like fractions, it is easy to add them up. So how do you add them? So the process is to add the top numbers, which are the numerators. So 2 plus 3. And then you divide that by just the what? The same denominator. So you're just going to keep one of them. So you're not going to do 7 plus 3, okay? So I'm going to tell you from experience because I failed a lot, learning how to add fractions and subtract fractions. So I thought I would just add the numerators, and also add the denominators, and those were not working. So I learned from my mistakes. I hope you learned too. So 2 plus 3 will be 5 divided by 7, and this is what you want. All right, let's go ahead and do the second part. So second one is 4 over 5 plus 3 over 10. So in this case here, you can see that we have the denominators are not the same. So you call this one unlike fractions. Unlike fractions. And how do you add them up? So you just need to do one simple thing. Okay. I know it might not be that easy, but I'm just saying. All right, so we have 5 or 4 over 5, right? So since we have 4 over 5, what we can do here is to make sure that 5 and 10 become the same. You have to do something to 5, right? To grow to become 10. So I'm thinking that I can multiply 5 times 2. So usually you do that by multiplication, okay, not by addition. So it will be 5 times 2, right? So if I can multiply 5 times 2, that gives me 10. So what I'm going to do here, go to the numerator and also do the same to keep the fraction the same. And that's what you call equivalent fractions. So instead of 4 over 5, I'm going to now write it as 8 over 10. You see, so 4 over 5 is equivalent to 8 over 10. So then I can now add my 3 over 10, and that gives me 11 over 10. So what I did is just to add the top numbers, the numerators, 8 plus 3 to get 11, and I'm dividing by 10. All right, so let's keep learning. It's getting more interesting. All right, let's go ahead and do some subtractions and see what we are looking at. So again, we're going to subtract 3 over 7 divided by 2 over 7. So to do this, we see that we have the same denominator, so we have a like fraction. So we're going to keep 7. So 3 minus 2 will be 3 minus 2. And 3 minus 2 is 1, and then we have 7. So we have 1/7 as the final result for this example. All right, moving to the next one. I want you to pause the video and try it yourself. See what answers you get. All right, again, we have here um, an unlike fraction. We have unlike fractions. So because of that, we need to multiply 5 by 2 and multiply 4 by the same number. Be careful not to multiply 5 by itself and multiplying 4 by itself, so it would not retain its original value. So what you want is make sure that you multiply with the same number. The same number on the denominator will go for the numerator. All right, so 4 times 2 gives us 8, and 5 times 2 will be 10. So we're doing this so that we can have, we can change from unlike fractions to like fractions. All right, so here now we have like fractions. So we can now do 8 minus 3. So 8 minus 3 is going to be 5, right? 8 minus 3 is 5, and 10 is 10. All right, so you do not subtract the denominator, so you just keep it the same. So what is 5 divided by 10? Can we reduce this fraction? I think we can, right? Okay, so what we can do here is notice that 5 can divide 10. So we would say 5 divided by 5. So be careful not to end up with 2 as your final result, okay? I've made this mistakes many times, and I don't want you to make the same mistakes. So what you want to do is to divide 5 by itself and also divide 10 by itself. And when you do this, it becomes 5 divided by 5 is 1, and 10 divided by 5 is 2, and there you end up with 1/2. And this is correct. All right, let's keep going. Getting more interesting. All right, let's go to the next one. So here we're going to look at multiplication. Multiplication and division are my favorites. Easier to deal with, okay? But sometimes the numbers might be a little high to manage. But then I would say it's easier to do multiplication. All right, so let's go. So in this case now, you do not need to worry about the fractions being like fraction or unlike fractions. You do not want to find common denominators. All right, so what you want to do here is just multiply the numerators. 2 times 3, divide that by the denominators multiplied. Oh, easy, right? Okay, so 2 times 3 is 6, and 7 times 7, that gives us 49. So be careful not to end up with 14. This is 7 times 7, 49. All right, great. So this is what we have in multiplication. I told you. All right, so when we try this problem here, let's see what we're going to get. So here again, we can do that as 5 times 4 divided by 8 by 15. All right, so here we get 5 times 4 is 20, and 8 times 15, that should give us 120. And again, we're looking at reducing this fraction because we can see the top number is it's an even number and the bottom is also an even number. And as a matter of fact, we can divide the numerator, top number, by 20, and also divide the denominator by 20. Sometimes you can do this to quickly get to the result. So, right, so 20 divided by 20 is 1, and 120 divided by 20 is 6. Your final result is 1 over 6. All right, but there's something I want to teach you that's called cancellation. Let me write that, cancellations. All right, because these numbers are a little too high, sometimes you might not realize how to reduce the fraction. But if you can cancel, if you can do these cancellations, you'll see it is very helpful. Let me show you. 5 over 8 times 4 over 15 is equal to, so let's go. This is what I'm going to do. I'm going to compare 5, since 5 does not divide 8 exactly, or 8 does not divide 5 exactly. I would rather compare 5 and 15, and then compare 4 and 8. So if I wanted to do my cancellation, I'll be looking to cancel 5 and 15. I know that 5 can divide 15 exactly to give 3. So, but what I'll do here, I'll cancel 5 and cancel 15 first. So canceling 5 means I'm going to divide 5 by itself and divide 15 by 5. So 5 divided by 5 and 15 divided by 5. So 5 divided by 5 is 1, right? Over, again, I'm going to do the same to 8 and 4. So 4 divided by 4 and 8 divided by 4. So 4 divided by 4 is 1, and 8 divided by 4 is 2, and 15 divided by 5 is 3. So look what I get. So 1 times 1 will be 1, and will be 1, and 2 times 3 will be 6. So look at that. So sometimes this is very helpful when you have um, large numbers to work with. Okay. All right, let's do this division. So for this division here, this is how I would show you how you can easily deal with problems like this. There's something that I call uh, keep, change, flip. Okay. Keep, change, flip. So what does that even mean? So I'm going to keep the first fraction, which is what, 2 over 7. Then you change the division sign to multiplication. So change means change the division to multiplication. All right. If I do that, I'm going to flip 3 sevens to 7 over 3. So I think I can say turn. Instead of saying flip, you can say turn. All right. So now it's become what? It's become like multiplication, right? So you just do the same. So 2 times 7, 14, 7 times 3, 21. And then you just check around to see if you can reduce the fraction. Of course, I can reduce this fraction. How do I reduce that? I see that I can reduce by dividing 14 by 7. So I'm going to divide 14 by 7 and divide 21 by 7 as well. 14 divided by 7 is 2, and 21 divided by 7 is 3. So we could use cancellation to do the same. So try that and see how you can use cancellation to get 2/3. Now, for this final problem here, I am going to write, okay, let's go ahead and write this out. So my only problem here is this number here. Looks weird a little bit, right? A little weird, and this is what you call a mixed fraction. Mixed fraction, or some people, or you can call that a mixed number, or you can say mixed number. Instead of mixed fraction, you say mixed number. All right, so I need to convert this mixed fraction or mixed number to what you call an improper fraction. Okay, an improper fraction is a type of fraction that has the numerator larger than the denominator. So let me show you what I mean. So okay, so here 3 whole number 1 over 3 can be done this way. So what you're going to do is, let me show you. This is what I'm going to do. The way to change this, or to convert to an improper fraction, is you start from the denominator. So the denominator is very important. So when you're dealing with fractions, what makes them fractions is the denominator. So you always start from the denominator. So I'm going to take this 3 here and multiply it by this 3. So 3 times 3, always in that direction. So then whatever I get, I will then add the top number. So you can see we go from multiplication then to addition. So that means 3 times 3 plus 1. Okay, 3 times 3 plus 1. See? So 3 times 3 plus 1, that gives me 10. 10 over 3. That's what I get for that. So I still have my division sign here. I'm just doing it backwards. And then I still have my 5 over 8 here. So look what I have. So I can just exactly solve it like the way I solved example A here on the division part. So here, I'm going to do my keep, change, flip. So keep 5 over 8, change, and then flip. That means 3 over 10. If I wanted to do my cancellations right here, I can easily do that and end up with a very nice number. But then let's go ahead and just say 5 times 3, 15, and 8 times 10 is 80. But then, we know that the last digit of a number is 5. That means that number is divisible by 5, right? And if the last digit of a number is 0, that means it is also divisible by 5. So which means we're looking to divide 15 by 5 as well as 80 by the same 5 so that we can get it down to the lowest fraction. Okay, lowest form of the fraction, or what you call the equivalent fraction. All right, so 15 divided by 5 is going to be 3, and 80 divided by 5 is going to be 16. So we end up with 3 over 16. So this is the end of my review with you for the slide. Okay, so make sure you subscribe so that you can have access to all the other videos that I've made previously and the ones I'm going to make in the future. Thank you so much for always coming here to watch our videos, and I will see you next time.